Assalamualaikum, my name is Muhammad Zazmi Aziz bin Mazlan. This research discuss the challenge faced by remote village in Sarawak, East Malaysia. In obtaining electrical power, this area often rely on conventional generator or government renewable energy for electricity. Despite progress, there is still room for improvement in achieve widespread coverage. The latest approach involves using software tools like Homer to design cost-effective microgrid with traditional and renewable power source. This research emphasizes the importance of considering various factors in the design process. It then focuses on using Homer to design photovoltaic system for electrification in Sarawak. Highlight the need for understanding the specific location of rural house. This research introduced a study on the optimal design of a PV system for rural electrification, detailing the evaluation, load estimation, and design stage using Homer software. The upcoming section will cover site visit, load estimation, design assessment, and the presentation of results. Objective for this research to work on a case study related to power system generation and transmission to demonstrate an awareness of the consideration for societal health, safety, legal and control issue, and the consequent responsibilities will conform to the relevant code, regulation and standard. Project scenario. The task is to bring electricity to a remote village using a solar microgrid. We will design a sustainable energy solution involving solar panel, energy storage and distribution system, overcoming the logistical challenge of transporting equipment to the village and ensuring a reliable power supply, which is seasonal variation are key consideration. Research on applicable code and standard. Safety code, electrical safety code Malaysia adapt to the electrical safety code and standard set by the Energy Commission of Malaysia. Suruhanjaya Tenaga. Environmental regulation. Environmental Quality Act 1974 Malaysia comply with Malaysian environment regulation to ensure that the installation and operation of the solar microgrid have minimal impact on the local environment. Grid interconnection standard. Grid code Malaysia. Follow the grid interconnection standard specified by the utility company or relevant authorities in Malaysia. Industry specific guideline. Renewable energy at 2011 Malaysia comply with regulation related to renewable energy project in Malaysia. Building code. National Building Code of Malaysia ensure that the installation of solar panel and related infrastructure complies with Building Code in Malaysia. Occupational Safety Act Standard. Occupational Safety Act 1994 Malaysia. Follow safety and health standard to ensure there will be of worker during the installation and maintenance of the solar microgrid. Product standard MSISO 13845 2013. Photovoltaic PV system consider the Malaysia standard for photovoltaic system to ensure the quality and reliability of solar panel and related equipment. Quality Management Standard ISO 9001 Quality Management System. Implement quality management practice to ensure that reliability and longevity of the solar microgrid component. And data protection in cybersecurity. Personal data protection 2010 Malaysia ensure that any data collected from monitoring the microgrid complies with data protection regulation. The last one, local community engagement guideline. Community engagement guideline, if available, if there are specific guidelines for engaging with local communities, adhere to them to ensure smooth project implementation.
Okay, my name is Nicholas Yapi, so I'm going to present about scenario overview for technical specifications. First, solar panel type monoset lead silicon capacity to be determined based on site assessment, efficiency, high efficiency of thermal power generation, mounting combination of fixed and tracking panels for increased efficiency. And second, energy storage type lithium-ion battery capacity size to store excess energy during peak sunlight for use during low sunlight or at night. Inverter convert DC power to AC power for household use. Number 3, microgrid controller. Smart microgrid controller for efficient energy distribution and load balancing. Remote monitoring capability for real-time performance tracking. Number 4, logistic and transportation. Compact and lightweight equipment for easy transportation. Local collaboration for assembling component on site. Number 5, community engagement. Educational workshop to inform the community about the benefit of the solar microgrid. Training program for local to handle maintenance tasks. So number 6 is sectional variation. First, storage capacity designed to address sectional variation and prolong period of low sunlight. Backup power source such as small scale generator for extended low sunlight period. Number 7, maintenance and support. Training program for local residents to handle routine maintenance. Remote monitoring system for real-time issue identification. Sustainability. Number 8, end-of-life consideration for proper disposal or recycling for solar panel and batteries. Community involvement in ensuring and sustainability of the system. Number 9, regulatory compliance. Its hand to regulatory compliance. Adherence to electrical safety costs set by the Energy Commission of Malaysia. Compliances with environment regulation to minimize impact on the local environment. Following grid interconnection standards specification by relevant authorized in Malaysia. Complying with the Renewable Energy Act 2011 and others industry specific guidelines. guideline. And lastly, monitoring and evaluation, establishment of key performance indicator (KPI) for monitoring system performance feedback. Mechanism to gather insight from the community on the system feedback. Okay, next for project goals. First, provide reliable electricity. Ensure a stable and reliable power supply for the remote village, meeting both current and future energy needs. Number two, community empowerment. Empower the local community by providing training and involving them in installation and maintenance processes. Number three, environmental sustainability. Minimize the environmental impact through bans and environmental regulation and sustainability practice. Number fourth, energy access. Improve energy access in remote village, contributing to the overall well-being and development of the community. And for expected outcome, first, energy security. The solar grid should provide an consistent and secure power supply, reducing dependence on traditional less reliable source. Number two, community involvement. Increase community involvement and awareness regarding renewable energy system. Number three, environmental conservation. Environmental regulation should result in minimal ecological impact. Economic development. Improve economic prospect through enhanced by energy access, potentially enabling small-scale business. For critical area and compliance. First, electrical safety. Next, for critical area of compliance. First, electrical safety codes. Critical for the safety of the community and the successful operation of the solar microgrid. Second, environmental regulation. Essential to ensure the project performed by measure environmental standard. Grid interconnection standard compliance crucial to ensure seamless integration with the existing grid infrastructure. Number four, Renewable Energy Act 2011. Today's act is fundamental for the legal operation of the renewable energy project. Number five, Data protection and cybersecurity. Ensuring the security for data located from the remote monitoring system to protect against potential cyber attack. Number six, local community engagement guidelines. Adhering to guidelines for engaging with the local community to ensure the project success and acceptance. That's all. Thank you.
Identify compliance risks and challenges. Number 1. Health and safety risk. Risk: accident during installation and maintenance. Challenges: implementing strict safety protocol to prevent accident. Number 2. Environmental impact. unintended ecological impact during construction. Risk, the challenges, establishing an effective waste management system for decommissioned component. Number 3, grid reliability. Inadequate capacity planning resulting in grid instability during peak demand periods. The challenges, coordinating with the utility company to ensure seamless integration with the existing grid. Number 4, compliance with electrical safety codes. The risk, inadequate grounding and bounding practice. The challenges, regular inspection and maintenance to uphold safety standard. Number 5, community engagement. Risk, resistance or lack of cooperation from the local community. Challenges, conducting effective communication and education campaign. Number 6, data protection and cyber security risk. Risk, unauthorized access to the remote monitoring system. The challenges, implementing robust cyber security measures to protect sensitive data. Number 7, seasonal variation backup power. Risk, failure of backup power system. Challenges, regular maintenance and testing of backup power source. Number 8, regulatory compliance. Risk, incomplete understanding of involving regulation. Challenge, regularly update the project plan to align with changing regulation. Number 9, economic viability. Risk, unforeseen costs are arising from changes in regulation. Challenges, establishing contingency plans for potential cost overruns. Number 10, local workforce training. Risk, lack of local expertise for troubleshooting issue. Challenges, developing a robust training program to empower the local workforce. There is 10 points of mitigation strategies. Number 1, comprehensive training programs. Conduct intensive training for the local workforce on safety, maintenance and troubleshooting. Number 2, environmental management plan. Develop a comprehensive plan for waste management and eco-friendly construction practices. Number 3, grid integration planning. Collaborate closely with the utility company to ensure grid reliability and compliance with interconnection standard. Number 4, regular safety inspection. Implement routine safety inspection and maintenance checks to uphold electrical safety codes. Number 5, proactive community engagement. Foster open communication channels, address concern, and involve the community in decision-making processes. Number 6, cyber security measure. Implement robust cyber security protocols and ensure compliance with data protection regulation. Number 7, backup system and storage planning. Size energy storage system accurately to handle seasonal variation and ensure reliable backup power. Number 8, continuous regulatory monitoring. Establish a dedicated team to monitor regulatory changes and update the project plan accordingly. Number 9, financial planning and contingency measures. Conduct a through financial analysis and establish contingency funds to address unforeseen challenges. The last one, number 10, ongoing workforce support. Provide ongoing support and training opportunities to the local workforce to enhance their skills.
Okay, now I'm gonna present about 11 code conformance strategy. Okay, firstly is initial assessment and planning. Okay, the objective is understand and identify all relevant codes, regulation and standard applicable to the project. The step is engage with local authorities, the Energy Commission of Malaysia and relevant regulatory bodies to identify and obtain a comprehensive list of applicable code and standard. Second, detailed design and engineering. Objective is integrate compliance requirement into the detailed design and engineering phase. Okay, the step is collaborate with experienced engineer and consultant familiar with local and international standards. Okay, Number 3 is local engagement and permitting. The objective is secure necessary permit and approval by demonstrating compliance with local regulation. Okay, the step is work closely with local authorities to understand specific permitting requirements. Number 4 is supplier and contractor compliance. Okay, this objective is ensure that all suppliers and contractors adhere to the specified codes and standards. Okay, the step is include compliance requirement in procurement, document and contracts. Number 5, construction and installation. Okay, the objective is implement the project according to the approved plan and specification while maintaining compliance. Okay, the step is enforce strict adherence to safety codes during construction and installation. Okay, number 6 is quality control and assurance. Objective is implement quality control measure to ensure that the system component meets specific standards. Okay, the step is establish a comprehensive quality control plan for all components, including solar panel, inverters, batteries, and other equipment. Number 7 is testing and commissioning. The objective is validate the performance and safety of the solar microgrid before handing it over for community use. Okay, the step is conduct through testing to verify that the system operates according to design specification and safety standards. Okay, number 8, community training and education. The objective is educate the local community on the safe and efficient use of the solar microgrid. Okay, the step is develop training programs that incorporate safety protocol and guidelines. Number 9, monitoring and maintenance. The objective is establish ongoing monitoring and maintenance practice to ensure continued compliance. Okay, the step is implement a remote monitoring system to track the system performance in real time. Okay, number 10 is regular audit and reporting. The objective is periodically audit the system to ensure ongoing compliance and report on performance. The step is conduct regular audit both internally and with external compliance expert. Okay, lastly is 11, continuous improvement. The objective is adapt to change in regulation and technological advancement to maintain long-term compliance. Okay, the step is stay informed about any updates or change in relevant codes and standards. Okay, next we go to 10 ethical and social consideration. Okay, the first is community well-being. Ethical implication is providing reliable electricity to a remote village improve the overall well-being of the community by enhancing living conditions, supporting education and enabling economic activities. Second is environmental impact. Ethical implication. Adhering to environmental regulation and sustainable practice demonstrate a commitment to ethical environmental stewardship. Number 3 is health and safety. Ethical implication is ensuring compliance with safety codes and standards is an ethical responsibility to protect workers, community members, and future generations from potential health and safety hazards. Number 4 is energy access and equity. The social implication is providing access to electricity in remote areas promotes social equity by bringing the energy access gap between urban and rural communities. Okay, number 5 is economic development. The social implication is the project can contribute to economic development by enabling small-scale business, creating job opportunities and supporting local entrepreneurship. Okay, number 6, cultural consideration. The social implication is understanding and respecting local cultural practice is vital for successful community engagement. Number 7 is data privacy and security. Ethical implication is protecting data privacy and ensuring the security of information collected from the remote monitoring system is an ethical obligation. Number 8 is local workforce development. And the social implication is training the local workforce not only contribute to the success on the project but also provide valuable skills for community members. Number 9 is inclusivity and accessibility. Social implication is ensuring that the project is inclusive and accessible to all members of the community, including vulnerable population aligned with social responsibility. Number 10, continuous community, the engagement. Social implication is ethical responsibility to maintain open and continuous communication with the community to address concern, gather feedback, and incorporate local perspective into decision-making process.
Next, for reflection and future improvement. So for the first one, reflection, we have 5 points, which is appreciation for comprehensive planning, balancing technical excellence with ethical considerations, community-centric approach, and recognition of holistic nature of engineer projects, and lastly, continuous adaptation and learning. So for the first one, appreciation for comprehensive planning. The project highlights the importance of comprehensive planning from the initial assessment to continuous monitoring and improvement, adhering to strict regulation necessities a true understanding of codes and standards, emphasizing the significance of meticulous planning in ensuring project success. Second, balancing the technical excellence with ethical consideration. The project underscored the need to balance the technical excellence with ethical consideration. It's not only about designing a technically sound solar microgrid, but also about considering the ethical and social implications of the project, such as community well-being, environmental impact, and inclusivity. So the third one, community-centric approach. The emphasis on community engagement and empowerment reshaped my perspective on power system engineer. It highlights the importance of tailoring project to meet the specific needs and cultural context of the communities they serve, ensuring that technology benefits are shared equitably. And fourth, recognition of the holistic nature of engineering project. This experience emphasizes the successful engineering projects go beyond technical proficiency. They require holistic understanding that includes legal, ethical, social, and environmental considerations. Compliance with regulation is not just a legal requirement, it is also a foundation for ethical engineering practice. So, and last but not least, continuous adaptation and learning. The dynamic nature of regulation, environmental taught me the importance of continuous adaptation and learning. Regulation can evolve, and staying informed about changes is crucial for maintaining compliance and ensuring the sustainability of the project. So for next future improvement, we have also 5 big points, which is enhanced collaboration with local stakeholders, integrating sustainable practice, investing in community education and training, and anticipating future regulatory changes and prioritizing data security and privacy. So for the first one, enhanced collaboration with local stakeholders. In future projects, I will place an even greater emphasis on collaboration with local stakeholders, building a strong relationship with the community, local authorities, and regulatory bodies is essential for successful project in implementing and a long-term sustainability. So for the second one, integrating sustainable practice to further improve future project. There could be a heightened focus of integrating even more sustainable practice. This includes exploring innovative technology, materials, and construction methods that minimize environmental impacts and promote long-term ecological health. For the third one, investing in community education and training. Recognizing the positive impact of community engagement, future projects could invest more research in community education and training programs. It's also ensuring that residents have a deep understanding of the system and actively participate in maintenance, contribute to the project's sustainability. And the fourth one, anticipating future regulatory changes. In an ever-changing regulatory landscape, continuous monitoring of regulatory change is paramount. Future improvement strategies should involve establishing robust mechanism of anticipating and adapting to future regulatory change to ensure ongoing compliance. And the last one, prioritizing data security and privacy. Given the increasing importance of data security and privacy, future projects should prioritize the implement of advanced cybersecurity measures. This includes not only protecting the integrity of the energy system, but also safeguarding sensitive data collecting from monitoring system. So to summarize all our video is, this research we can conclude that we emphasize the holistic and sustainable approach of the solar microgrid project in addressing energy needs in a remote Malaysian village. It highlights the project's adherence to the codes, standards, ethical consideration, and managerial risk, and also challenge through proactive mitigation strategy. Ethical and social consideration reflect a commitment to community well-being and environmental stewardship. Reflection underscore the importance of meticulous planning, balancing technical, expertise, and ethics, and also adapting to a dynamic regulatory landscape. Future improvement suggestion for on collaboration, sustainability, community educations, and anticipating technology advancement. The solar microgrid project serves as a model for aligning renewable energies initiative with a regulation, prioritizing ethics, and fostering sustainable development within local communities. That's all. Thank you.